Yeah, good evening, good afternoon, good morning, depending on where you're watching me from. Ramjak Max is here again. Although we'll be looking at just one question, but I want to build confidence in one of my students, David, a very brilliant student, is here to uh, teach us this symmetry matrix. So please have confidence he can deliver and try to encourage him. What do you say you are studying? Mechanical, yeah. Mechanical production, yeah. Although is it education? Yeah, education. Yeah. So I want to build confidence in him. Please love, like, comment, and share. Thank you, and God bless you. Okay, over to you.
Thank you, sir.
Yeah, over to you. All the best. It's okay.
Hello. Good afternoon, good evening, depends on where you are watching from. Like stated earlier, my name is David, and I'll be taking you on this question here, which says express the matrix A as the sum of symmetric and skew-symmetric metrics. So please, it's not something difficult, so I want you to pay close attention as I'll be solving it, and in case you have any question in the process of solving, do well to drop it in the comment section. Amen? All right. And thanks to Ranger Max, my daddy, for giving me this opportunity to stand here and deliver this. Thank you so much, sir.
You're welcome.
All right. Now, the question say express the matrix A as the sum of the symmetric and skew-symmetric metrics. Now, when they say express the matrix A and the sum we know that it is plus. So they are trying to tell you to find the symmetric matrix of matrix A. This is matrix A. And then you should also find the skew-symmetric matrix of the same matrix A. And then after finding it, you should add it together. Amen? You should add it together. So, first of all, how are we going to find the symmetric and skew-symmetric? Let's write our solution. The formula for finding a symmetric matrix is as simple as half, open bracket, the matrix minus the transpose, or plus, sorry, the transpose of the matrix. Half times, well, open bracket, the matrix A plus the transpose of the matrix A. What do you understand by transpose of a matrix? It's like simple as changing the rows of the matrix to become the columns, and the columns of the matrix to become the rows. Let's do it together. Now, we have our matrix A to be equal to 4, 2, minus 3, 1, 3, minus 6, minus 5, 0, minus 7. This is our matrix A. Now, what is our transpose for this matrix? The transpose for this matrix is, it can be written as, let's do it like this. It can be written as A to the power of T. This is how it is written. So there is A transpose, and it's equivalent to, like I stated earlier, is changing the rows to become the columns, and the columns to become the rows. Let's do it. So if 4, 2, minus 3 were the first row, we are going to change it to become the first column. 4, 2, minus 3. I don't know if I understand it. And then the same thing, we pick the second row to become the second column. This is going to be 1, 3, minus 6. And then Same thing, we are going to pick the third row to become the third column. So this is going to be minus 5, 0, minus 7. You have successfully found your A transpose. This is your A transpose. So it's as simple as, now if you look very well, your first column here has become your first row, and your first row here has become your first column. Everything here has changed. So now this has become your A transpose. Now coming back to the equation, we say half times A plus A transpose. Having known A and known A transpose, why not substitute it inside? Let's go. So we have A, that is half, and then open bracket, our A, we say is what? 4, 2, minus 3, 1, 3, minus 6, minus 5, 0, minus 7. Right? And then plus our A transpose to be 4, 1, minus 5, 3, 0, minus 3, minus 6, minus 7. I believe you all are following. Any questions so far? This is the point where we are. Any question? If you have any question, please do well to drop it in the comment section. Alright, I believe I can clean this side so that we move forward. Okay. Yeah, let me start here. Alright. Now, we are going to add these two metrics together. Now, the addition of metrics is very simple. You just pick the first number here, which is called element. Pick the first element, add the first element on the other side, like that, till the last one. Let's do it together. So this is going to be 1 over 2, open bracket, that is 4 plus 4. That is this 4 plus this 4. And then if you are moving to 2, we do 2 plus 1 minus 3 plus open bracket minus 5. Why did I put it in bracket? Because we know definitely if you don't put it in bracket, you will have a wrong answer because of the word, the sign, negative and positive sign. That is why I decided to put it in bracket. Then, coming down here, we have 1 plus 2, 3 plus 3, and minus 6 plus 0. Then to the last one, minus 5 plus open bracket minus 3, 0 plus open bracket minus 6, and minus 7 open bracket plus open bracket minus 7. Then close it. This is the addition of the two metrics. Now let's find the final answers. 4 plus 4 will give us 8. 2 plus 1 will give us 3. Minus 3, negative positive will give us negative. So minus 3 minus 5 will give us negative 8. That's negative 3, negative 5 will give us negative 8. Then 1 plus 2 will give us 3. 3 plus 3 will give us 6. Then negative 6 plus 0 will still give us negative 6. Negative 5, negative 3 will still give us negative 8. And then negative, 0 negative plus negative 6 will still give us negative 6. And then negative 7 negative 7 will give us negative 14. This is how far we have come. Now, we are going to be opening the bracket by dividing each of these elements by what? By multiplying each of these elements by half. And if, for instance, if you say 1 all over 2 times, let's say 8, it's the same thing as saying this 8 here is all over 1, and then 1 times 8 is 8, 2 times 1 is 2, which is give you 8 divided by 2 will give you what? 4. So this is what we are going to be doing here. Each element will be dividing by what? By 2. Amen?
Amen.
Alright. So this is going to be equal to 8 divided by 2, 3 divided by 2, minus 8 divided by 2, 3 divided by 2, 6 divided by 2, minus 6 divided by 2, let's expand, minus 8 divided by 2, minus 6 divided by 2, and minus 14 divided by 2. So this is going to result to 8 divided by 2 will give us 4. 3 divided by 2 will not give us the whole number, so it will still remain in a fraction form. Minus 8 divided by 2 will give us a minus 4. 3 divided by 2 still remain in a fraction form. And then 6 divided by 2 will give us a 3. Minus 6 divided by 2 will give us a minus 3. Minus 8 divided by 2 will give us a minus 4. Minus 6 divided by 2 will give us a minus 3. And minus 14 divided by 2 will give us a minus 7. This is where we have come so far. I believe you are done with this side, so I'm going to erase it so that we finish this particular one. Please, in case you have missed any step, you can do what to drop it in the comment section right here with you to answer all your questions. Alright, now we have arrived at the final answer. So let's name this new equation or new matrix. Let's name this new matrix any alphabet. You can name it C, you can name it D, you can name it F, you can name it anything. So as for me, I'm going to name this matrix D. So you say let D be equal to this matrix 4, 3 all over 2, minus 4, 3 all over 2, 3, minus 3, minus 4, minus 3, minus 7. So this is our D. We are going to be using it in future so that we can determine the sum of the symmetric and skew symmetric. So now this is the solution for the symmetric. Now let's move to finding the skew symmetric of the same matrix A. Let's move to find the skew symmetric of the same matrix A. Now in symmetric matrix, I would say our formula was half open bracket A plus the transpose of A. Now in skew symmetrics, in finding skew symmetric, we are going to be using the formula A will be equal to half open bracket A minus A transpose. That is the difference. In symmetric, we are dealing with positive, while in skew symmetric, we are dealing with negative. So when you see a question like this, you know that in symmetric, It's still the same formula. The only difference is the sign in between the A and the A transpose. In symmetric, we have positive as the sign in between them. Meanwhile, in skew symmetric, we have the negative sign in between the matrix A or any given matrix and the matrix transpose. So now let's bring it together. We already know our matrix A, and we already know the transpose of what? Of matrix A. Now, in finding the skew symmetric, it's going to be half open bracket and matrix A. We say is 4, 2 minus 3, 1, 3 minus 6 minus 5, 0 minus 7. And the negative sign here will now come minus. We know our transpose, like we used earlier in finding the symmetric, to be 4, 1 minus 5, 2, 3, 0, minus 3 minus 6 minus 7. This is the transpose of the matrix A. So please, if you are done, let me clean this side. All right. Now, we are still going to apply the same operation that we did previously, but here we are going to be using a different sign. Previously we used plus, now we are going to be using subtraction. Now, we say half open bracket in the matrix 4 minus 4, then 2 minus 1, then minus 3 minus open bracket minus 5. Take note, this is minus 3 and the 5 here is also having a minus sign. So that is why we have minus 3 minus 5. Don't forget to write the sign of the minus that is in front of the 5. Now, let's move to the second row. We have 1 minus 2, 3 minus 3, minus 6, minus 0. Let's move to the last row. Minus 5, minus 3, 0 minus 6, and minus 7 minus 7. Close your matrix. Now the next thing we are going to be doing here is we are going to be finding the final answers of each of these. So this is going to be equal to 1 all over 2, open bracket, the matrix 4 minus 4 will give us 0, 2 minus 1 will give us 1, minus 3 minus 5, this is going to give us a plus. So minus 3 plus 5 is going to give us a plus 2. Then 1 minus 2 is going to give us a minus 1. Then 3 minus 3 is going to give us 0. Then minus 6 minus 0 is still going to give us minus 6. Then 5 minus 3. Negative will give us positive. Minus 5 plus 3 is going to give us a minus 2. And then negative is going to give us positive. Then 0 plus 6 is going to give us what? 6. Then negative minus 7, negative is going to give us a positive. Then minus 7 plus 7 is going to give us a 0. Now we are going to be dividing or multiplying all through by 1 over 2 like we did previously. So this is going to be matrix 0 all over 2, 1 all over 2, 2 all over 2, minus 1 all over 2, 0 all over 2, minus 6 all over 2, minus 2 all over 2, and then 6 all over 2, and 0 all over 2. See? So, now we are going to be finding the final answers. 0 divided by 2 will still give us 0. 1 divided by 2 will still 1 over 2, because it cannot give us a whole number. 2 divided by 2 will still write 1, because 2 divided by 2 is 1. Then minus 1 all over 2, we are still going to write it in fractional form. 0 divided by 2 will give us 0, and then minus 6 divided by 2 is going to give us a minus 3. Minus 2 divided by 2 is going to give us a minus 1. And then 6 divided by 2 is going to give us 3. And then 0 divided by 2 is going to give us 0. So this is the answer for finding the skew symmetric matrix of matrix A. This is the skew symmetric matrix of matrix A. So we are going to name it like we named previously the solution of symmetric matrix of matrix A to be D. We are going to name this one to any alphabet. So we say, let E, we are going to name it E, be equal to let E be equal to, then you write the matrix 0, 1 all over 2, 1, 1 all over 2, that is minus 1 all over 2, 0, minus 3, minus 1, 3, 0. So you have found your E, you have found your D, you have found your symmetric, and you have found your skew symmetric. Now they ask you to what? Express the matrix A as the sum. As the sum. So that means you are going to add the symmetric and the matrix together. So let's add it together. Permit me to clean here. Yeah. Okay. Now, say matrix A should be equal to D plus what? E. Where we know that D is the word symmetric, solution of the symmetric matrix, while E is the one of what? The skew symmetric matrix. So now let's add it together. Our D was 4, 3 all over 2, minus 4, 3 all over 2, 3, minus 3, minus 4, minus 3, minus 7. And then plus our E. 0, 1 all over 2, 1, we have minus 1 all over 2, 0, minus 3, minus 1, 3, and 0. Right. So now, we are going to be adding it together. Then it will look like this. 4 plus 0, 3 all over 2, plus 1 all over 2, minus 4 plus 1, 3 all over 2, plus 1 all over 2, 3 plus 0 minus 3 plus open bracket minus 3 minus 4 plus open bracket minus 1 minus 3 plus what? 3 and then minus 7 plus 0. So now we are going to be finding our last answer for that particular question. We say 4 plus 0 is going to give us 4. Now, I know you might have had a little understanding of adding fractions, and there's a saying in mathematics, or a law in mathematics rather, that when the denominators are the same, you pick one denominator, you either add or subtract the powers depending on which type of operation you are performing. So in here we are having two denominators which are the same. So what we are going to do here, we are going to pick one of the denominator, which is 2, and then we add the numerators. The numerator here is 3 and what? 1. 3 is here plus what? 1. And 3 plus 1 will give us what? 4. And then 4 divided by 2 will give us what? 2. So without wasting time, we're going to substitute or put 2 here. And then moving to the next one, which is this, minus 4 plus 1 will give us what? Minus 3. Now, same thing you are going to do here. Same thing you are going to do here. Oh, sorry. Here is supposed to be minus because of this minus sign. Supposed to be minus. Also, the minus sign that is here is affecting it. So, this is going to be, since the denominators are the same, you pick one denominator and then you what? Subtract the numerators, which is 3 minus 1 will give you what? 2. 2 divided by 2 will give you what? 1. So we are going to have 1 here. And then 3 plus 0 will give us 3. Minus 3 minus 3. Because negative and positive will give you what? Negative. So it's going to be minus 3 minus 3, which is equivalent to minus 6. So we are going to have minus 6 here. And then minus 4 minus 1, because positive, negative, negative. Minus 4 minus 1 will give you minus 5. Minus 3 plus 3 will give you 0. Minus 7 plus 0 will give you minus 7. So now you can see that the addition of symmetric and skew symmetric matrix of matrix A is the same thing as matrix A. You can see this is matrix A. Our final answer in adding is still matrix A. So this is to show you that if for you to validate or know that your answer is correct, at the end of adding the symmetric and skew symmetric of that matrix, it should be able to point you back to what? To the matrix. So this is the solution for this particular problem.